All right, we're back. Now we're going through questions on the chain rule. Okay, you forgive my lack of vocabulary. It'll be a bit challenging to explain this, but listen. Here's what I want you to know. This that I've written here is the reminder to say, remember, dy dx is equal to dy du times d dx is the formal way of getting the chain rule. There is an informal way that works, that is shorter, of getting the chain rule. But the reason why I still make you know the formal way is because you need it when you do connected rate of change. So either way, we're going to be answering all our questions in both ways, formal and informal, or short and long, whatever you want to call it, proper, improper, I don't know. But the two ways we're going to be using them. There's a shorter one, which I'll teach you, which you always use when you get just easy, straightforward chain rule questions. But if you were to get a connected rate of change, then you'd need to know, to have knowledge of this formal way. So that is why I always make sure you know. What does the chain rule say, the formal way? It says that if you want dy dx, you're going to have to say to multiply dy du by du dx. You're going to say to me, what is dy du? Remember we said, I'll say it again, we'll be having a function or a y with respect to x. Okay, y is equal to something x, blah, blah, blah. But we won't be able to find the derivative right away. So what we're going to do is we're going to introduce a new guy called u. And as you see, when we do questions, u is going to be the inside function. All right, we'll make the inside part be equal to u. And then when the inside part is equal to u, of course, the inside part will be written in terms of x. So if you say u is equal to whatever x it is, then that means you can now find du dx because u is now equal to something x. You see with examples. And then now that you've made u the inside function, you can now rewrite your y in terms of u, and you can get dy du again. You multiply these two, you're going to get a final solution. And of course, at the end of the whole thing, you replace u again with what it is. You replace it with the x part, and then you have your solution. So let me see. I've put down the stages in simple terms here to say, let stage one, let the inside function be u, and then rewrite y in terms of u. Then you can find your dy du and your du dx. Then you can use the chain rule to say, if you want dy dx, you multiply dy du. Remember, dy is derivative of y with respect to x. But right now I'm going to speak in funny language, but it helps you to understand. Listen, you want y to be at the top, right? So in your chain rule, make sure that you always have u. You always have du, because du is what makes the chain rule be the chain rule. Okay, it's a new guy that is coming in that is going to be there on the two stages. So we have a du here, and we have a du on the other one. But now, the place where you put du is the place where you don't want your guy to go. So anyway, here I want dy to be at the top. So dy is going to have to be with du, and dx again is going to have to be with du. So both of them are going to have to be with du. But you want to know, is it going to be dy over du or du over dy? What is it going to be? Well, dy, you want dy to be at the top, right? Yes, so you're going to have to find dy du. And you want dx to be at the bottom, right? Yes, so you're going to have to find du dx, x at the bottom. Okay, you multiply these two and you'll be fine. But don't worry, when we do it in practicality, you don't even need to remember all that. Okay, but just so you remember what the chain rule says. Okay, just so you remember what the chain rule says in the formal way. That's why I was trying to remind you. You want dy dx, but you're going to have to multiply two guys that have du's. And since you want dy to be at the top, so it's going to be dy du times you want dx at the bottom, so it's going to be du dx, x at the bottom. So yeah, when you get those two, then you're going to result in dx, in dy dx. Okay, that's the chain rule. You get it. Let's go and do questions. Let's do questions, and then you understand. And I'm going to teach you the shorter way. The shorter way is you differentiate the outside, and you know the funny thing, when you differentiate the outside, you actually use the power rule. Okay, so you're going to differentiate the outside using the power rule, then you multiply by the derivative of the inside using the power rule again. That's the shortcut. Okay, and you'll be done. You have the solution to your chain rule. Let's do questions. Here's the first one. Find the derivative of this. So, first thing I want you to know is how to identify that this is a chain rule question. Chain rule questions are composite functions. Okay? Like the one we're having right now. What do I mean by composite function? You have a function inside another function. Okay? In this case, you say, is there a function inside a function in this case? Yes. Look, the power of 9 we would say is our outside function. Okay? That is how we're going to do it. And this 3x minus 5 is the inside function. So raising to the power of 9 is the outside function. And then 3x minus 5 means you're going to, x will be the value you put in, right? You're going to multiply it by 3, then you subtract 5 from it. That's what the inside function is doing. The inside function is multiplying by 3, then subtracting 5. It gets a number, which is your x, multiplies by 3, then subtracts 5. Then the outside function is just raising that answer to a power of 9. Whatever is in the inside to a power of 9. Okay, so we have these two. One is raising to the power of 9. The other one is this 3x minus 5. So we are going to use the chain rule in here because we have a composite function. So it's easy. You just have this whole 3x minus 5 or whatever is inside, and it's raised to a big power outside, to another power outside. Whatever the power is, it could be a negative or positive power, I don't care. Once we have it like that, the only way to find your solution is to use chain rule. All right. What is the former way? You would say, remember that you would have y is equal to, open bracket, 3x minus 5 to the power of 9. Okay. So I'm going to say let u be equal to, so we said you let u be equal to the inside function. So it's going to be equal to 3x minus 5. The inside function, hello, that is what you make u be equal to. Never forget that. So now I can rewrite to say y is equal to u to the power of 9. Because you said let u be equal to 3x minus 5. So that means y is equal to, instead of writing 3x minus 5, you are putting u, because that's what you said u is. Now that I have these two, u being equal to 3x minus 5 and y being equal to u to the power of 9, I can find two very nice things. I can say du dx is equal to, because I have u being equal to 3x minus 5, so du dx is just equal to 3, right? And dy du, because I have y in terms of u, so I can find dy du. It'll be equal to, I use the power rule again. I bring down the power, 9. Then u to the power of 9 minus 1 is 8. Okay? You can go again and check the power if you're forgetting this. So I have these two, and I'm done. Once I've reached this stage, oh my, the solution is done. I could now say dy dx, okay, dy dx is equal to dy du, which I found, the derivative of y with respect to u. Because y is depending on u. When u gets a value, then it's raised to the power of 9. It is raised to the power of 9, then you get your y. And u is depending on x. When x gets a value, it is multiplied by 3, subtracted from 5, you get your u. So anyway, we got u with respect to x because u is depending on x. Okay? U is a function of x. So if you want the derivative, it will be du dx. U as a function of x. So it's the derivative of u with respect to the x, the independent variable. Then here you have y is equal to u to the power of 9. That means y is a function of u. So when you want the derivative, it is dy du. The derivative of y, which is the name of your function, which is the outside guy, with respect to u, which is the independent variable, the one that affects everybody. Okay. So anyway, there we go. We get our solutions. We would now say it is dy du times du dx. Okay. Then it is equal to, what is dy du? 9u to the 8 times, what is your du dx? 3. What is this going to be equal to? Numbers multiply, 9 by 3, you get 27, you get u to the power of 8. But what is your u? You let u be equal to 3x minus 5. So at the end, you now replace. U is equal to 3x minus 5. So it will be equal to 27 multiplying 3x minus 5, and it is raised to the power of 8. This is the formal way. What is the shortcut? I'm going to put it here. Say or. Here's our shortcut. We have y be equal to 3x minus 5 to the power of 9. This shortcut, you always use it when you have basic questions like this that just say find the derivative like that. What do? You say dy dx, the derivative of the outside of your derivative, the one you want straight away. Okay, the final one, this dy dx, we can find it straight away. What is it equal to? You differentiate the outside using the power rule. What does the power rule say? Bring down the power. So we bring down 9. Then we rewrite just 3x minus 5, it doesn't change. Then we reduce that power by 1. So it'll be to the power of 8. Then times the derivative of the inside. What's the derivative of 3x minus 5? We differentiate 3x, we get 3. We differentiate negative 5, we get 0. So it'll be times 3. And it is equal to, now we say 9 by 3, we get 27. Multiplying 3x minus 5 all to the power of 8. This is done. Are the answers the same? Exactly so. 27 multiply 3x minus 5 to the power of 8 here. Then 27 multiplying 3x minus 5 to the power of 8. So you see the solutions are the same. The longer one, you have to let the inside function be u. Then rewrite y in terms of u. Find dy du and du dx. Multiply the two. Done. In this shortcut, we differentiate the outside using the power rule. Then we multiply by the derivative of the inside. We get our final solution. Look at two more problems you're done. Find the derivative of this guy. Okay, same concept. The moment I see this 5x squared plus 1 all raised to a power outside, then definitely I know that this is going to be the chain rule. But for me to use the chain rule, I'm going to have to rewrite because I shouldn't have my fraction. So I would say, okay, y is equal to 2 over, what is this? It is 5x squared plus 1 to the power of 4. I'll rewrite my y. Y will be equal to 2 is multiplying what now? 5x squared plus 1 is now to the power of negative 4. Okay, remember 2 was at the top, so you don't write it as a fraction. It's just going to be a number, a whole number, 2, then multiplying whatever, that stuff. You should know how to do this. It's in the videos on prerequisite knowledge indices, the indices. So you can go and check. Now here, what do we have? We can use the chain rule now when we have this. Okay, let's go the longer way. The longer way, why are you going the longer way when there's that shortcut? It is, you don't use this longer way. I wouldn't recommend unless necessary to use this longer way in a question like this simple type, but I'm making you know it very well because you're going to need it on rate of change. So anyway, we say let the inside function be u. So let u be equal to that inside function, which is 5x squared plus 1. Okay, let u be equal to that inside thing. Then I can now rewrite out, say y is equal to 2 multiplying u, because that 5x squared plus 1 is u, and it's to the negative 4. Now I can find if u is equal to this, then I could say, if I want to rewrite, since I'll be having space, I could jump 2 lines and say u is equal to 5x squared plus 1, put a comma, and now say du dx will be equal to 2 by 5, okay, it becomes 10, x to the power of 2 minus 1, the power reduces by 1. Then the derivative of this positive 1 is just 0, because it's a constant. Then I rewrite y is equal to 2u to the negative 4. That means dy du, the derivative of y with respect to u, it is equal to, remember that is a dy du, it is equal to negative 4 by 2, the signs are different, your answer is negative 4 by 2 is 8, then u is equal to the negative 4 minus 1. So it will be equal to negative 8 u to the negative 5. That is your dy du. Why did I do it in the longer way? Just to make sure you're safe. Then now I can say the one I want, dy dx, is equal to dy du times du dx, which is going to be equal to dy du is negative 8u to the negative 5 times du dx is 10x. So this is going to be equal to, you multiply the numbers, 10 by negative 8, the signs are different, your answer is negative. 10 by 8 is 80, and then it's 80x, then u to the negative 5. This x just comes, right? So it is equal to negative 80x multiplying, what is u to the negative 5? What is u? You said let u be 5x squared plus 1. So it will be multiplying 5x squared plus 1, and it is now to the negative 5. You are done. Okay? Or the shortcut. Or what is going to be the shortcut? You start here. Okay, when I have it this form, and I have it in this form, so I would say y is equal to 2 multiplying 5x squared plus 1 all to the negative 4. Now I can go ahead and find dy dx, easy capeasy lemon squeezy, very fast. What is it equal to? I use the power rule for the first thing, differentiating the outside. Then I'm going to multiply by the derivative of the inside. So what is the derivative of the outside? Negative 4 by 2. The signs are different. Your answer is negative. 4 by 2 is 8. Then I just bring the inside like it is, 5x plus 1. I don't change the inside in the first step. I don't care about it. And then my power is reducing by 1. It was negative 4. If I subtract 1, I would get negative 5. You can just say negative 4 minus 1 if you're not sure. Then times, you multiply, you always multiply by what? The derivative of the inside. 2 to 5x squared, if you differentiate it, will be 2 by 5 is 10. Then x, the power reduces by 1, will be just 10x. Then from here, we can go ahead and get it to say dy dx will be now equal to 10x by negative 8. The signs are different. Your answer is negative. 10 by 8 is 80x. Then what do? You just bring in 5x squared plus 1 to the power of negative 5. You are done. You are done. Are the answers the same? Let's zoom out so we can see. Oh, yes, negative 80x. I can see negative 80x. Then 5x squared plus 1, yes, to the negative 5. Wow, done. So that's beautiful, right? You see that it's nice? Exactly. That's the shortcut, right? The shortcut is what you always use when you have such simple everyday questions. But I want you to notice, without falling asleep, be quick to notice that this is a chain rule question because I have a big function inside which I can actually differentiate, and that whole thing is raised to another power outside. See the last question. This is a more practical question. These are the type of questions you could expect in an exam. The curve, blah, 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 passes through the point. Now, if you didn't know, this again is revisited in coordinate geometry, which is your unit 3. Whenever you have a curve and they tell you a point that it is passing through, okay? If you have a curve and you know the point that a curve is passing through, then that means you're only left with one more thing, and that is the gradient. And you can be even able to find if you have a point, right? They said the curve here passes through the point and has the gradient at this point. Find the value of A and B. So whenever I have a point where the curve is passing, I can be able to put those values when I have Y, I have X. I can be able to put those values in my Y and in my X position, and I can find any constant that's missing. So I have this point called 0.63. The moment I have that point, I'll be like, okay, I can put, because remember that a point is a coordinate, right? It has X and it has Y. So your X will be 6, your Y will be 3. So where there's Y, I put 3. Where there's X, I put 6. Then I can be able to find the constants. But the reason why they're giving us more info right now is because we have 2 constants, A and B. Now, if you have 2 constants, you're going to need to have 2 equations. So that means knowing that alone is not enough. We're going to need to know a certain way to find another equation, which when we combine that equation and the easy one, which we'll find from knowing these 2 points, if we combine those 2 equations using the simultaneous equations method, we will be able to find both unknowns. Okay? We'll be able to find both unknowns, A and B. And what is the other part? They've told us that this is the gradient 1/9. And the moment we know about a gradient of a curve, we know that we have to differentiate. No question about it. Okay? So let's go ahead and do these 2 things. We know that y is equal to the square root of ax plus b, right? Now, they've given us a point where it passes through, so we can say let x be equal to 6, y equal to 3. Okay, we can put that in. So that means wherever there's y, we're putting 3. So 3 will be equal to the square root of a multiplying x is what? X is 6 now, and then plus b. So we can now say 3 is equal to the square root of 6a plus b. And we could take the square root to the other side. If you're not sure, you could watch some videos that I have on subjects of the formula. I'll put the link in the description. So this square root goes to the other side. You now have 3 squared, and it is equal to 6a plus b, right? 3 squared is 9, is equal to 6a plus b. You say, why are you doing that? Because in the first equation, we have to make one of the letters the subject, either a or b, and we can now put it in the second equation we're going to make. So 6a goes to the other side. 9 minus 6a is equal to b. This is going to be your first equation. If you want to call it equation 1, it's up to you, so that you can communicate with the invigilator. Now, what is the second equation? Because the moment I saw the 2 points where the curve passes through, I know I can just put it into the original equation, and I can find any constants if there are any constants. Okay? But now, because I had 2 constants, that means I need 2 equations. What is the way of getting the second one? I've been told about the gradient of a curve. So, oh my, I can go ahead. I would say y is equal to the square root of, is it ax plus b? Yeah, it is ax plus b. The square root of ax plus b. Now I'm going to differentiate because I want to find the gradient of this curve. So for me to differentiate, I don't need the square root sign. So y will be equal to ax plus b together, and it is to the power of half. Because remember, we said every root, when you change it to a power, it will be the denominator of that power in a fraction. Now, the moment I look at this, I know this is a chain rule, because inside is ax plus b. This whole thing together is raised to a power outside. The whole thing together. So I'm going to have to use the chain rule. So anyway, we could go the longer way or the shorter way. In this case, now that I think you now know the longer way, okay, of letting the inside be u, well, let me just do it. Let u be equal to the inside, which is ax plus b, exactly as it is. then that means you'd say y will be equal to u to the power of half, because this whole ax plus b is now u. So now you could rewrite to say u is equal to ax plus b. You put a comma, that means du dx will be equal to, this ax you differentiated just becomes a. Then b is the number you differentiated, becomes 0. Then you can now say y is equal to u to the half. That means dy du will be equal to, half comes down, the power comes down, and you reduce the power by 1. So it will be u to the power of half minus 1, you get negative half. Then you can now say dy dx is equal to dy du times du dx. Okay? Which is going to be equal to, what is my dy du? Half u to the negative half. Times, what is my du dx? A, it's the letter A. So here I'm going to get it. Let me continue where there's space. Okay? Here, I'm going to get it as half a u to the negative half. And I could change it. Okay? It's going to be half a, and then u is what? You said let u be equal to what? Here, you said let u be equal to ax plus b. So it's going to be half a multiplying ax plus b to the negative half. Okay? If you want to write it in a better way, these 2 is in the denominator, right? So I'm going to put 1 times everything on the numerator. What is everything in the numerator in this line? I have 1 and a only. So 1 times a will be just a. Okay? Don't have space, man. What would I do? It's going to be a, then all over, what is in the denominator? There's 2, and then there's ax plus b. It is raised to the negative half. So if I put it in the denominator, it will be ax plus b raised to the positive half. And any number raised to the power of half is square root of that. So it's going to be equal to the last line, a over 2 root of ax plus b. This is going to be your derivative, your dy dx. Remember that this is your dy dx. So I could now write to say, wow, took a lot of space. So I could now write to say, remember you always have space. If you're done, if you're finished the space on a paper, you could write at the back, they have more space. You can now say your dy dx will be equal to a over 2 root ax plus b. We could use the shortcut and still get here, right? We could use the shortcut. If you want to see me do it, I'm going to write it in. I'm going to write it then rub it off because we don't have space. I add my here, y being equal to this. Of course, I'm going to have to change it to be in this notation. So I would have it say y is equal to half multiplying ax. Oh, what am I doing? Need to rewrite it to say y is equal to ax, let's write it properly, ax plus b to the power of half. Chain rule time. We go. We differentiate the outside and we multiply by the derivative of the inside. So it'll be y is equal to, differentiate the outside, you bring down the power half, and then we have ax plus b, doesn't change. We subtract the power by 1, it now becomes negative half. Then times the derivative of the inside, the derivative of ax is just a, the derivative of b is nothing. So you end up going exactly where we were. Half a multiplying ax plus b to the negative half. And we got that like here. That is the same stage that we had here. And of course, we would then have to put the power of half in the denominator to be positive. Then we change it to be the square root. And we are done. So basically, that's it. Wow. All right, so I'm going to erase this shortcut. If you wanted it, you can rewind the video, pause, and write it down. But for lack of space, I'm going to remove it. Okay. And then, what are we going to do? Well, once it's like this now that we have the, what is it that we have? We now have our dy dx. Where did we write it? Did we write it anywhere safe? Yeah, we wrote it here. We have our dy dx. Now we were told what that dy dx, it was 1 over 9. At the point, 6, 3. Okay, you have to be told the point. Remember, you can't get the gradient as an answer, as a number, unless you know where. Because gradients of curves keep changing. We know that. So here we'll say, when x is equal to, what was it? 6, right? When x is equal to 6, dy dx will be equal to 1 over 9. So I could say 1 over 9 now, the dy dx is equal to a over 2 multiplying the square root of a by 6. Okay, a times 6, which I could just write it as 6a, then plus b. So now when it's like this, I can cross multiply because I have like a fraction on the left and a fraction on the right, one thing like that. I cross multiply like that. 9 by a, 1 by this. So it's going to be 2 root of 6a plus b is equal to 9 by a is 9a. Like that. Okay, so this is going to be my equation number 2. Okay, this is going to be my equation number 2. Equation 2. But now I know what b is, right? Do I? Yes, because in my equation 1, I said 9 minus 6a is b. So where there is b, I can go and put 9 minus 6a. So it's going to be 2 square root of 6a plus 9 minus 6a. Okay? And this is equal to 9a. Okay, if I say plus 9 minus 6a like this, still this, I'll have it as 2 root of 6a plus 9. This plus will be the plus 9. Then plus minus, the signs are different. Your answer will be negative. So minus 6a is equal to 9a. And then it will be 2 root of 6a minus 9a. This is a 9, so I need to make it bigger. 6a minus 6a becomes 0. We have root of 9 is equal to 9a. What is root of 9? Is 3. So 2 by 3 is equal to 9a. 6 is equal to 9a. And then 9 goes to the other side. 6 over 9 is equal to a. What is 6 over 9? We can divide both by 3. We get 2 over 3 is equal to a. That is your first solution. Okay, that is your first solution. 2 over 3. Beautiful work. And then to get your b, you just go back to equation 1, the same equation 1, and say 9 minus 6a is equal to b. So you can say 9 minus 6a is equal to b. Okay, here. And then I can say let a be equal to 6 over 9. So I could say 9 minus 6 multiplying 6 over 9 is equal to b, right? It becomes 9 minus 36 over 9 is equal to b. All right? So 9, we know that it is like 81 over 9 minus 36 over 9 is equal to b. And when it's like this, you could go ahead and find your solution. I'm trying to quickly put my calculator on. Okay, and I can get, sorry, give me a second, almost done. It's going to be 81 minus 36. Okay, let's see, 81 minus 36. 45? 45. Took me a long time. I'm sorry, right? So it's going to be, anyway, 45 over 9 is equal to b. 45 over 9 is 5. So, okay, so 5 is equal to b. You're done. You get full marks. Beautiful. So anyway, did you see the stages? I hope you're writing down on a paper so that you can write it down neater, okay? Better than I did, and you can be able to analyze the solution better. All right, but this is what it is. Goodbye. Thank you for watching. See you in the next round of videos.